G'day team, and welcome back to another Applications of Calculus video, and today we're going to be looking at rates of change. Now, when we're doing the derivative, we are actually in fact looking at rates of change. It just is kind of the language we used when we first introduced it right back at the start of the Introduction to Calculus playlist. Now, when we're looking at a derivative, we've actually got d by dx, which means the change in my function over the change in the x step. So pretty much in my rise over run. Now, the other way we could look at this is dy by dx is the rate of change of y at x or with respect to x. Now, this logic can be applied to any function name or variable that we want to differentiate with respect to. So for example, if I have the height given by h of t, and t is time, then dh by dt, so the rate of change of h with respect to t, that is exactly what I've got written here. So we treat it just like a normal y equals or f of x equals function with respect to x. However, t is now the function we use and h is the name of our function. All right, so it's still the same sort of idea as what we've been doing. We're just putting different labels on it now. So let's have a look at an example. So the height of a tree t years after being planted is given by h of t equals 60 plus 40 times ln t t 2 times t, got it out, plus 1 centimeters. Now t is greater than or equal to 0 because it is time. Time cannot be negative. So to start with, how tall was the tree when planted? So we want to find the height at t equals 0. So this is for A. We want to find h of 0. Now let's put 0 in for t. Oh, so I've got my numbers around the wrong way. 60 plus 40 ln 2 times 0 plus 1. Now the ln of the natural log of 1, because that little 2 times 0 cancels out, I've got the natural log of 1. That is equal to 0, so I'm just left with 60 centimeters. All right. Now you can use your calculator and throw it in there. That's more than fine. Part B, how long will it take for the tree to reach 100 centimeters? Now I'm going to do it algebraically, but you can check on your calculator. Put the function into your graph and just substitute in y equals 100 and you'll find your t value. But we're going to look at what happens when we do it algebraically. So I might copy down my function, just like that, duplicate that, bring that down here, just so I've got it there to refer to. So bi. Now we want to find when it's equal to 100. So 100 here equals 60 plus 40 natural log of 2t plus 1 in my bracket. So I'm going to subtract 60 from both sides and then divide by 40. So I've got 40 over here divided by 40 is 1. It's the natural log of 2t plus 1. And we all know to get rid of a natural log, we raise each side e to the power. So on the left, I've got e to the power of 1, which is equal to 2t plus 1. Now, to get t by itself, we subtract 1 and divide by 2. So t equals e minus 1. Oh, that's not a nice little line for me. Over 2. And if we put that into our calculator to get a nice decimal for our time, we get shift E 1 minus 1 over 2. We get 0.859 years. Okay. Now let's have a look at I. So that is going to be when it's 450 centimeters equals 60 plus 40 ln 2t plus 1. So subtract 60 is 390. 390 divided by 40, that's 39 over 4, which is equal to the natural log of 2t plus 1. And again, I'm now right at this point here where I raise both sides into the power of e. And then I'm going to do the same rearranging. All right, so I've got t equals So I have 2t plus 1, so I'm going to subtract 1 from e to the 39 on 4, minus 1 divided by 2. So putting that into our calculator, change that e power to be 39 over 4, and we get 8,576.6 years. And they are actually both approximate values. Okay, so that's how to do it algebraically. Obviously, we can do that nice and easily on our calculator. Now, I'll just move this down a bit. So we want to now solve C, which is at what rate is the tree growing after 3 years and 40 years. Now, that is asking for what is the derivative at t equals 3, at t equals 40. So let's find the derivative of my function. So I've got 60 plus 4t ln 2t plus 1. Now that 60 is just a constant, so that disappears. So I'm left with 40, and I know the derivative of a natural log is the derivative of the inside of the log divided by the inside of the log. So it's going to be 2 on 2t plus 1. So this is, h dash of t. Now if I bring that together, that's going to be 80 on 2t plus 1. Now if I find h dash of 3, which is what it's asking for in I, I've got 80 divided by 7, or if I just go down onto my calculator and do the fraction, 80 divided by 7 is 11.43 centimeters per year. Okay, so the amount it's grown per increment of time. And then h dash of 40 is equal to 80 over 81, or 80 over 81 as a decimal, 0.988 centimeters per year. So you can see the rate of growth over time gets significantly less as we move through. Hopefully this helps a little bit. It's a nice little question to do. Have a go at some questions in the textbook, and thank you for watching. We'll see you in the next video.